Hello everyone, welcome to the video lecture series of operating system. In today's session, we are going to continue with the topic memory management. Specifically, we are going to discuss virtual memory concept in this particular session. Myself Kunal Panchal, your instructor. In this particular session, specifically in virtual memory, we are going to discuss page replacement algorithms. And in page replacement algorithm, we are going to discuss first in, first out page replacement algorithm. But before going to discuss first in, first out page replacement algorithm, let us understand first what is the requirement of page replacement algorithm. Okay, or can say what is the significance of page replacement algorithm? Why it is needed? That we need to understand first. Okay, so what is page replacement algorithm? So why page replacement is required actually? So as we have discussed in paging technique, the main memory is divided into a fixed size frames. And each frame contains pages of a particular process. Okay, so that we have already understood in paging. Now what will happen? We have finite amount of main memory in our computer system. Means what maximum we have 16 GB RAM is available nowadays. Yes. So we have finite size of memory, and we cannot accommodate all the processes from the secondary memory and put it into a main memory at the same moment of time, because the size of secondary memory and the size of main memory is different in terms of size. Okay, or can say capacity. Like secondary memory, we have 1 TB, 2 TB hard disk is available, but all the programs we cannot accommodate into a main memory for execution. That is not possible. So what we need to do is, because if that programs needs to be executed in the CPU, as you know very well, that programs needs to be converted into a process, and that process needs to reside in main memory. Then and then CPU can execute that processes. Okay, so there is a concept of memory issue, memory storage issue we can say. Okay, so what will happen in this case? So this is our limitation. We cannot do certain things in it. Okay, so what we need to do in this case? So suppose if we in real practice, what will happen? Suppose if we have 10 programs which are loaded into a secondary memory, and that 10 programs need to be loaded into main memory at a same moment of time. So what will happen? Instead of fetching whole programs from the secondary memory and putting it into main memory, what we are doing in nowadays, because we do not have that much sufficient space through which we can accommodate 10 programs. Okay, so what we will do, instead of a whole process, or I can say programs, as you know very well, process is divided into a number of pages. Okay, fixed size of frames we have, and frames contains different pages. So ultimately the process contains a single process contains set of pages. So instead of copying whole process from the secondary memory and put it into main memory, what we do, we will put some selected pages from that process into main memory, as per the demand. Means demanded pages will be fetched from the secondary memory and put it into a main memory for execution. And later on, means as per the size of the main memory, we can fetch that pages from the secondary memory. But what will happen in this case if we do not have the sufficient space to accommodate the selected pages of that number of processes? In that case, we need to do certain things. Suppose, for example, if main memory is already full, now if CPU requires one page from a particular process and which is located into a secondary memory right now, so what we need to do is we cannot fetch that page and put it into a main memory because main memory is already full. So what will happen in this case if such type of situation occur? And this type of situation occurs frequently in the case of memory management scenario. So if such type of situation occurs, in that case page replacement algorithm will come into the picture. In this case, what we need to do is we need to take one of the page from the main memory and that page needs to be replaced with the upcoming page which is coming from secondary memory and put it into a main memory. This is what these two pages will be exchanged. Okay, one is coming from secondary memory to main memory and another is coming from main memory to secondary memory, and this concept is called swapping in virtual memory. It means what? It is nothing but swapping, swap out concept. Means the process, the page which is going to secondary memory, that is nothing but swap out process, and the process is a page which is coming from secondary memory to main memory, it is nothing but swapping process. Okay, so such type of things are required because that page is required to execute certain things in a particular process by the CPU. So if CPU demands that page, definitely that page needs to reside in main memory anyhow. If it is not available, in that case we need to use this page replacement algorithm and fetch that page from the secondary memory by using the concept of swapping, swap out, and then at the end CPU will execute that process. Okay, so this is the significance of page replacement algorithm. Okay, so let us discuss. There are various page replacement algorithms are there, but out of which in this particular session we are going to discuss the first and simplest page replacement algorithm, which is nothing but first in first out page replacement algorithm. It is also known as FIFO page replacement algorithm. Okay, let us discuss the first in first out page replacement algorithm with example. So in the example, in your examination you will have such type of reference string would be given to you as an input. So you can see the reference string of a particular process means actually these are the various numbers. So I have written reference string of process P1 means for ease of understanding I have taken P1 process. You can take any P2, P3, P4. You can suggest any name, but you need to keep this in your mind. There is one process, okay, and that process needs to be executed in the CPU. Okay, and but that process contains these number of pages. This is the sequence of pages of a particular process, and these reference strings tells us the 701203042303120. These are the number of pages, and this sequence represents what? First of all, CPU needs to require 7th number of page of a process 1, then it requires 0th page of process 1, then it requires 1 page of first page of process 1. So this is the order they have mentioned. So according to this order, okay, we need to execute this task. So what we need to do is, I hope it is clear up till now, because this is reference string and this reference string contains number of pages of a particular process, and this process is nothing but P1 in this particular example, and this is the sequence in which these pages need to be processed. Clear? Okay. Now one more thing you will have at the time of examination as an input, not only reference string but also how many number of frames are there, that also would be given to you as an input. So in this particular example, okay, there are 3 frames are given. So in this particular table you can see F1, F2 and F3. Okay, I have taken bottom up approach. You can take top down approach as well. Okay, so F1, F2 and F3, these 3 are nothing but frames, and this frame, how many number of frames are there in main memory, that will be given to you as input. Means what? This table is nothing but this table area is nothing but you need to consider this is nothing but main memory. Okay, this table is nothing but main memory, and this main memory is divided into 3 fixed size of frames. So which is nothing but F1, F2 and F3. Okay. I hope up to this it is clear to you. Now means what? Now we have a number of pages, and these pages needs to be accommodated into a particular sequence into this frame. So initially the table entry was empty. Okay, so because this is a snapshot I have taken for a particular scenario or at a particular moment of time, but initially this main memory was empty. Now we have 3 different frames, and the size of the frames are equal, and these frames contains number of pages, but these pages are not loaded into main memory yet. Now we are going to load this number of pages that is given to us as an input. Okay, like 7012 onwards, right, and so on. So these pages need to be loaded into this particular table, or can say in main memory, right? So what will happen in this case? So if you want to load these pages, at the same time you have to concentrate, okay, which algorithm we are using for page replacement first in first out. Means the senior most page we need to consider for replacement first. Okay, let us discuss these things with the help of this example. So first of all, what we'll do, you can see this particular table, the first column. So first reference string we will take in sequence is nothing but 7. 7 number page needs to be loaded into a frame. So right now all the frames are available. So I will simply put 7 into a first frame, which is nothing but F1. Okay, but this is nothing but page fold. This operation, because initially the main memory do not contain any pages, and this set of pages which is given to us as an input, these pages are right now loaded into a secondary memory. So when CPU demands 7th number of page of process 1, at that time we are fetching that page from the secondary memory and trying to put it into a main memory in this case. So it means what? When CPU demands at that time, we do not have that page in main memory directly, but CPU require that page for its execution. So what operating system will do? Operating system will take the responsibility and fetch that page from the secondary memory and put it into a main memory. So initially it was not there, and somehow we have managed and get that page from the secondary memory. So this activity or this scenario is nothing but we can say page fault. Okay, so that page fault I have represented in terms of star. So you can see in each column I have mentioned star as well as hit. So what hit means that we will see later on, but star means what? There is a page fault. Okay, because CPU demanding a particular page which was not available in main memory. Okay, so that is the reason why it is called page miss, or we can say page fault, and that is represented with the help of star in this particular example. I hope it is clear. Okay, now the second page will come. Second page is nothing but zero page. So what we'll do? Okay, we have 3 frames and only 1 frame is occupied right now, so we can put 0 in the second frame directly. Yes or no? Yes, because we have enough space right now. So F1 is only occupied now. F2 would be occupied by 0. Now the third request is 1. 1 is again we have one free slot we have, which is nothing but F3. So we can accommodate 1 in that case. So 701 is easily occupied in the main memory, and these 3 operations would be considered as page fault operation, or we can say page miss operation, because all the pages which required by the CPU was not available in the main memory directly. Okay. Now the fourth page number is 2. So in this case, now we do not have any space in main memory because all the frames are occupied with the different number of pages. Yes. So when this 2 page wants to store into a main memory, what will happen? In this case, now the first in first out page replacement algorithm will come into the picture. Now in this case, we need to use the page replacement strategy, which is nothing but first in first out in this case. So when 2 needs to enter into main memory, so 2 needs to be replaced, means swap in swap out operation, because we do not have any memory, so we need to swap out 1 page from the main memory. So we have 7, 0 and 1. So which page needs to be swapped out? So first in first out. Based on this manner, we need to swap out 1 page from the main memory. So first in. So which was first in? 7. So 7 needs to be replaced with 2. I hope it is clear. First in, first out. Okay. So 2 would be replaced in this case. So the 7 is replaced by 2 and remaining value 0, 1 would be as it is. Okay. So is there any page fault in this case? As far as 4th column is concerned, yes, it is considered as page fault. That's why I have denoted it into in terms of star. Why? Because in this case also we have fetched that page from the secondary memory. Yes, we have used the concept of swapping, but ultimately we have fetched that page from the secondary memory. When you are fetching the pages from the secondary memory, definitely that would be considered as page fault. Okay, so that is page fault. Now the next request is 0. 0 is already present or not, that we need to check. Okay, so 0 is already present. Yes or no? 2, 0 or 0 is already present. So in that case, if CPU require particular page and if that page is already available in main memory, okay, in that case there is no miss. It is nothing but hit. So that is represented with that of hit, and same value will be copy paste in the next column 2, 0 and 1. Now the next page 3. So first of all we need to check is 3 is already available in the main memory, 3 is not available in the main memory, so definitely 3 needs to be replaced. So 3 will be replaced with which value? So definitely first in first out. So earlier we have used F1. Now we need to use F2. So 0 needs to be replaced with 3 in this case. And is there any page fault? Definitely it is considered as page fault. So 2, now the updated value in the upcoming column is 2, 3 and 1. Now the next request is again 0. Okay, so in this case what will happen is 0 is already available in the existing column. No, it is not available. So 0 needs to be replaced with first in first out, means F3 frame. Yes, because earlier we have taken F1, F2, and now the turn is nothing but F3 frame. So F3 frame value needs to be replaced with 0. So now the updated value is 230. Okay. Now once we have this value, now again what is the next request? That is nothing but 4 pages required. So we first of all need to check, is there page number 4 is available in the main memory? The answer is no. So what we need to do is we need to execute first in first out page replacement algorithm. So now in this case F1 value needs to be replaced. So 2 needs to be replaced with 4. So now the value becomes 4, 3 and 0. And is there any page fault? Yes. Whenever these things you need to keep in your mind, whenever you require to fetch the content from secondary memory, that operation would be considered as page fault. This is simple and short logic you have to understand. Okay. So these page fault occur. Now the next request is 2. We need to check 2 is already available. No, it is not available. Now in this case we need to replace with F2. Value of 2 is replaced with F2 frame. So now the updated value is what? In the next column 4, 2 and 0. Okay, is there any page fault? Yes, it is considered as page fault. Now next one, 3. 3 is already present. No, 3 is not present in this case. Okay, so which value will be replaced by 3? So 0 would be discarded and 3 would be put in the F3 frame. Okay, now the updated value is 4, 2, 3. Okay, now is there any page fault? Yes, it is considered as page fault. Now the next request is 0. Okay, is there any 0 available in the existing value of main memory? No, 0 is not available. So again we will replace the value 0 with 4 because now the turn is F1 frame. Okay, so 4 is replaced by 0 and the remaining values are as it is 2 and 3. Okay, is there any page fault? Yes, this would be considered as page fault. Now next one is 3. Next requirement is 3. Is there page number 3 is available in the main memory? Yes, it is available already in the main memory. So these existing value of main memory will be simply copy paste into a second or into a next column. So 0, 2, 3. Fine. So this would be considered as hit, not miss. Yes. Okay. Now next one is 1. 1 page number is already exist. It is not exist. So now the 1 value will be replaced. Okay, so F2 frame value will be replaced with 1. Okay, so now the updated value is 0, 1, 3. Is it page fault? Yes, it is considered as page fault. Now the next request is page number 2. So page number 2 is already exist. What is not exist? So again we will replace that page with existing page. So now the term is frame number F3. So F3 value is replaced with 2. So now the updated value is 0, 1, 2 and this is nothing but page 4. Now the last page is nothing but 0. So 0 is already present. Here it is present. So it means what? The same value will be copy paste into a next column, and these operations will be considered as heat operation because the required page of CPU is already available in the main memory. So by having this understanding, how many heat we have at the end? So 1, 2 and 3 heat are there, and how many page misses or page faults occur in this particular example? So we can calculate 4 plus 4 and plus 4 is equal to 12. So how many page faults? 12 page faults are there. And if somebody asks you what is the heat ratio and means ratio, so we can easily calculate with the help of this set of outputs we have, like heat is 3 and page fault is 12, and how many number of pages we have, total number of pages. So that we need to calculate 3 plus 3 6, 6 plus 3 9, 9 plus 3 12, and 12 plus 3 15, means total 15 pages we have. So if we want to find out heat ratio and means ratio, we can easily find out with the help of this formula. So heat ratio is equal to number of heats. How many number of heats in this case? 3. Okay, divided by total number of references, means what? Total number of reference strings, or we say total number of pages we can say in this case. Okay, so it is nothing but 15. So 3 divided by 15 multiplied by 100. Now the final outcome of heat ratio is nothing but 20%. Same way, if you want to find out means ratio, definitely the means ratio we can easily find out just like this. So what was the number of heat? 12. 12 divided by 15 multiplied by 100. Okay, so the means ratio would be 80%. Okay, so this is all about first in first out page replacement algorithm, in which it suffers from high means ratio, more number of page fault as compared to number of heat. So this is main drawback of first in first out page replacement algorithm. In the next session we will discuss the another page replacement algorithm. So I hope whatever we have discussed in this particular session was clear to you. Thanks for watching this video. See you in the next one.